climate change shock. Scientists say that freshwater lakes could cause greenhouse gases to double. Freshwater lakes causing climate change to worsen dramatically as researchers reveal greenhouse gases released from beneath the surface could double as our Earth warms. This is according to Sean Martin, Express UK. The researchers found that as our planet warms, the amount of plant matter in freshwater lakes could rise and lead to double the amount of methane and carbon dioxide could almost double. This is the study from what was concluded from the University of Cambridgeshire, simulated the effects of climate change on freshwater lakes, for example, in Canada. They found that as the water warms, plant matter in the lakes rises, according to research published in Proceedings of National Academy of Sciences at the United States of America, PNAS, and it's because of longer summers, milder winters creating greater diversity. Plants decompose and are taken by microbes in the water, and the more plant matter translates to more microbes, increasing the amount of methane and CO2 being released by an average of 1.5 to 2.7 times more. This is what Dr. Andrew Tanzap, Cambridge Department of Plant Sciences, says, and he's led the research on this. This is what we've traditionally called carbon in fresh water. Turns out to be a super diverse mixture of different carbon-based organic molecules. And he explains, we've been measuring carbon in fresh water as a proxy for everything from water quality to the productivity of freshwater ecosystems. Now we've realized that it's the diversity of this invisible world of organic molecules that is important, he says. And he goes on to explain climate change will increase forest cover and change species composition, resulting in a greater variety of leaves and plant litter falling into the waterways. We found that the resulting increase in the diversity of organic molecules in the water leads to higher greenhouse gas concentrations. Understanding these connections means we could look at ways to reduce carbon emissions in the future, for example, by changing land management practices. Then he said that the next part of the study will focus on how sediment formed of the lake floor will affect greenhouse gases, stating that discovery could determine just how long humanity has to battle these consequences. He says not all organic matter that reaches lakes is digested by microbes. Some sinks to the lake floor to form the muddy sediment, locking away the carbon. And the amount of sediment formed will also increase with climate change, but we don't yet know how much. And so to what degree this increase is stored carbon will offset increased greenhouse gas emission from lakes. Answering this question will be crucial in improving the accuracy of carbon accounts and assessing how much time humanity has to balance them. So according to Andrew Tanzap, who is the reader in Global Change Ecology, University of Cambridge, as the conversation states, on a microscopic scale, lakes are anything but calm. An invisible metropolis of microbes feeds on these logs and leaves, producing greenhouse gases as a byproduct, and as a result, the lakes may be responsible for as much as a quarter of the carbon in the atmosphere, and it's rising. The new research conducted with my colleagues in Cambridge, Germany, and Canada, he says, suggests that emissions from freshwater lakes could double in the coming decades because of climate change. All known life on Earth is made of carbon. When plants and animals reach the end of their lives, microorganisms such as bacteria and fungi come to feast. They feed on the carbon-based remains of other organisms and their waste products, collectively known as organic matter. As byproducts of this never-ending feast, microbes release gases such as carbon dioxide and methane into the environment, and while each individual microbe releases a minuscule amount of gas, they are the most abundant organisms on Earth, so it adds up. Energy from sunlight can also break the chemical bonds between molecules of organic matter, releasing smaller molecules such as carbon dioxide into the environment. Some of this degradation happens on the forest floor, but much of the organic matter that falls into the ground ends up in the water. Winds, rain, and snow transport it into the lakes, or more often into the rivers that feed them. The amount of greenhouse gases released from lakes by microbes and sunlight is huge. Initial estimates were about 9% of the net carbon released from the Earth's surface to the atmosphere. That is the amount released over and above the Earth's carbon storing processes. But thanks to improved measurements, the recent research has revised the figure to as high as 25%, not 9%, 25%, so it's a quarter. These numbers are substantial given that the lakes only comprise about 4% of the global land surface. In the coming years, lakes will receive more and more organic matter from microbes to digest. A warming climate will bring more forest cover around lakes and a greater proportion of broad-leaved trees such as maples and oaks as compared to needle-leaved trees such as pines. Carbon is 1,000 forms. To understand how changes to forests will alter the role that lakes play in the carbon cycle, we performed an experiment in 2 Canadian lakes. We filled plastic containers with rocks, sand, clay, and different amounts of types of organic matter from nearby forests. This was intended to mimic the change in forest cover and composition expected from climate change. We then submerged the containers in shallow lake waters where organic matter is most likely to accumulate and monitor them for 3 years. Using new techniques to analyze the carbon chemistry of water, we found that those containers simulating a level of forest growth expected in the next few decades led to between 1.5 and 2.7 times more greenhouse gases in the water than conditions simulating today's forest conditions. The invisible diversity of organic compounds in the water was the most important factor causing this rise, even more important than the diversity of microbes and the overall amount of organic matter. The likely explanation for this result is that the same microbes can feed on many different types of molecules. So as the number of carbon-based compounds in the water increased, there are more ways for microbes to feed and release greenhouse gases. The increase in diversity of organic matter alone was enough to raise greenhouse gas concentrations by 50%, but the size of this effect nearly doubled in containers with darker overlying waters, a scenario expected in most lakes as climate change brings increased tree cover. Accurately tracing how carbon makes its journey from land to atmosphere is vital to predict the pace of climate change and mitigate its effects. By better understanding how the vegetation around lakes controls greenhouse gas concentrations in water, our research can inform whether changing the way we manage land near lakes can help reduce carbon emissions. For example, we might want to plant fewer aquatic plants such as cattails in lakeside areas because they produce much higher concentrations of greenhouse gases than organic matter from forests. Work also remains to understand fully the role lakes play in the carbon cycle. Not only organic matter that reaches lakes is digested by microbes, some sink to the lake floor to form muddy sediment, locking away carbon. The amount of sediment formed will also increase with climate change, but we don't yet know by how much. And so to what degree this increase in stored carbon will offset the increased greenhouse gas emissions from lakes. Answering this question would be crucial in improving the accuracy of carbon counts and assessing how much time humanity has to balance them. If you'd like to join me on my Patreon account, you will hear content not covered by mainstream media. These riveting stories will be based on my research, and I will state my opinions and give my personal insight on diverse and controversial subjects and world events not covered by mainstream media, and not certainly on not supported by YouTube guidelines. So whatever I have on my Patreon, most of those will not be on my YouTube channel. Please consider becoming a member today. More of the most significant and important videos will be on my Patreon channel. Your support helps me to continue my research and keeps this YouTube channel alive. And we depend on your support, your generous charity, because we help economically challenged families here in Athens, Greece, in Kapota, and we also help the young generation with university tuition and the community around our church. Thank you.